what we're going to look at next are the natural numbers specifically. So just to kind of review, I know we've been over it, but the natural numbers start at the number 1 and go on forever. So I've got it written out there, 1, 2, 3, 4, and then that ellipse means it keeps on going. So the number 10's a natural number, 100's a natural number, 5,000's a natural number. Everything past that's positive that keeps on going up is a natural number. And there are an infinite number of items. Natural numbers do go to infinity. This is a really weird symbol, and it's the Aleph null. Aleph null means countably infinite. And there's a typo here. This means that you can count. Sorry about that. You can count the number of items. I also refer to this as like fancy N there. But it is called Aleph null. You could also write it kind of like that. A lot of times people write that scribble on there. That's the symbol Aleph, and null is the symbol at the bottom, that 0. It is a subscript. All right, a few more things, then we'll jump into some problems. The same number of items, as we've already said, means that we have the same cardinality. So what we're going to be trying to do is set up this one-to-one correspondence between the natural numbers and this other new set. If they are the same, then this other new set also has cardinality Aleph null. All natural numbers have cardinality Aleph null. That's their answer. If we're looking at the natural numbers, their cardinality is Aleph null. It's infinite, so there's not an actual answer there, but that's my symbol to say infinity. So now we're going to look at these to see if they are the same size. So I'm going to be looking at this set. It looks almost like the natural numbers, but it does not include the number 1. So you might think, hey, this is smaller because it doesn't have the number 1 in it, but the natural numbers do. So what I'm going to do is I'm going to list out the natural numbers. Then I'm going to list out my set that I was given. So the natural numbers are right here, and there's that set. And I'm going to make that pairing that we saw before. So every one of the natural numbers has one of the numbers in the new set. You might be saying, well, you could go on to the next one, and you're totally right. I could put 5 on the left-hand side and 6 on the right-hand side. And I could keep doing that all day long. And there would always be a next number. So I'm not going to do any more because I don't want to make the video that long. I want to be able to stop it at some point. So these guys are the same size. This set is also Aleph null. Its size is Aleph null. Again, you might be thinking, but it doesn't have the number 1 in it. It doesn't matter. They are still both infinity. They are still both countably infinite. And there's a little formula that I can show how these pairings would go on and on and on and on. Maybe I want to know what the number 100 pairs with, or the number 558. I can find a formula for this. The natural numbers are always called n every single time. So I want to know how I get 1 to turn into 2, or 2 to turn into 3. And it looks like each time I'm adding 1. And this down here, and I'll highlight it, this is the important part. We need to get down to that formula. That finishes the problem. And for these, when we're showing our work, you need all the setup. You've got to have this part up here, you've got to have the ellipse, and you've got to have down here. You've got 3 parts to show that both of these sets are literally the same size. They are both Aleph null.